Greetings, and welcome to another exciting Math 310 video. Today we're going to talk about measures of center, which you can find in chapter 15.3 in your textbook. Specifically, we're going to introduce the ideas of mean, median, and mode, and then towards the end we'll talk about kind of which one is best as a measure of center for data. So what I want to use to introduce this idea of measures of center is an activity that goes really well with students in a classroom. But I'll try to kind of walk through the basics of it and see if we can't still get some of the benefit. So we imagine that we have a classroom full of students, and we're going to give everybody a box of these tiny boxes of raisins. So for this example, I'm just going to use 6. We'll pretend we're in a classroom with only 6 students. Each student gets their own box of raisins. What we're going to have them do is open up the box, pour them out, and count how many raisins are in their box. All right. So let's say each student counts their raisins, and these are the quantities that they come up with. So the question that I want to pose to you is, if we were going to collect all the raisins together and then share them equally to everyone, how many raisins would each person get? So I'd like you to pause the video and work out, if we were going to put all the raisins together and then share them equally among the 6 students, how many would each person get? Okay, so one way to go about doing that is to put all the raisins together and get a total count of raisins. So we can put all these numbers together, add them up, and we find that there are 156 raisins in total. Now, if we want to share them equally among 6 students, you can think of that as dividing 156 into 6 equal groups, and that would make 26 raisins per person, per student in this arrangement. That is actually a really lovely way to think about the mean of a data set as a kind of an equal sharing idea, where you sum up all the data into a total and then you distribute it equally among the number of elements there are in the data. So in this case, you can also think of this as like, what is the mean amount of raisins in a little tiny box? And so we had 6 boxes, we take the total and then divide it up. And I misspoke there because I said average. And I want to be clear, and I want us to try to be clear, that average is actually a way to kind of talk about what's typical, and mean, median, and mode can all be thought of as averages of a data set. They can all be a way to talk about what is typical in a data set. And so we want to be specific that when we're talking about adding up the elements and then distributing them equally, we're describing the mean of a data set, which is a specific kind of average. So I want us to try to break that habit of talking about average as the adding up and then dividing by the number. But there's another way, as I mentioned, to talk about a typical element in the data set, or a measure of center. And so what we're going to do now is we're going to arrange the raisin boxes in order. In this case, we'll go from least to greatest number of raisins. And what we're going to look at is what's in the middle. When we arrange the raisin boxes numerically in order this way, what is in the middle? Well, unfortunately, there are 6 elements, so there isn't a box that's exactly in the middle, but it's somewhere between 24 and 26. And so when this happens, we look at the mean of those 2 elements that are on either side of the middle. And that thing we call the median. The median is the middle of the data set when it's arranged in order. And so in this case, we would look at the mean kind of halfway between 24 and 26. So the median is 25. And in general, the median is the middle element when you arrange the data in order. And so just to summarize, the median of this data set is 25. The mean of this data set was when we took the total number of raisins, 156, divided it equally among the 6 students. And so that gave us a mean of 26 raisins. And that's kind of the equal sharing model. And in general, when we talk about the mean, what you want to do is sum up the elements and then divide by the number of elements. So in this case, there were 6 elements, so that's why we divided by 6. The other measure of center that we haven't addressed yet is called the mode. And in this data set, there isn't a mode, because the mode is the element that occurs most frequently in the data set. And arranging them numerically, the data, can be a useful way to visually spot the mode, because everything is kind of clumped, right, in order. So you can see which element appears most. Now, in this case, there isn't any one that appears most because every data set is unique, or every data point is unique. But we'll talk more towards the end of the video about when the mode is a really useful measure of center. So another way to think about the mean that can be kind of nice is as a leveling out. So let's say we wanted to find the mean of these 5 numbers, 4, 3, 6, 5, and 2. What we could do is we could think of making stacks of blocks to represent each of those digits. So the 4 yellow blocks represent the number 4, the 3 green, the number 3, and so on. And so what we can do is we can actually think about sharing the blocks among each of those 5 stacks to find out what the average is, or the mean in this case. And the mean would be 4, because when we distribute all the blocks evenly and level them off so they're all the same height, exactly 4 fit in each tower. Now, this isn't my favorite way to think about mean. I actually really prefer the equal sharing. And part of the reason is because you can get into trouble with frequency plots if you think about this leveling out idea for the mean. So what we'll do in the next clip is we'll look at some frequency plots and try to understand a better way to think about mean in those cases. So here you can see a little applet that I found that's going to help us investigate some properties of the mean and the median and different kinds of data sets. And we're also going to look at what's called a dot plot or a frequency plot. So we'll see how we can visualize data very briefly to look at these ideas of another way to look at mean and median specifically. So at the top, I just want to kind of briefly explain. I'm going to share a link to this page so that you can play with this too. And in fact, I would invite you to pause the video if you haven't already and pull up this page. So when you click on this bar with the data, a cursor shows up. Now, you can't highlight with the mouse, unfortunately, but if you click inside, you can use the keyboard to move around, and you can make your own data sets. You just have to put commas between the numbers. Right? This isn't going to be a very interesting one, but we can plot that. And what it's going to show us, well, you can see there's nothing on here, but you can use your mouse to grab the number line. So if you click and drag, you can slide it over. And if you're hovering over it, you can also zoom in with like the mouse wheel. Or I guess probably a multi-touch on your, if you have a trackpad on your laptop or something. Maybe even on a touch screen. I don't know. Anyway, so what it did was it gave us a dot plot. Now you'll notice there's a dot over 1, 2, 3, and 4. And there's only one dot because there's only one of each number. If I went up to the list and I put in another 2, it would put another dot. Now there are 2. The value 2 shows up twice in our data set. So it's a frequency plot. How frequently do these numbers show up? All right. So in the last segment, I mentioned that in frequency plots, this idea of leveling out can be really problematic. So let me show you what I mean by that. Let's say that we had a data set that was 9, 9, oops, got to put in the commas, 10, 10, 10, and 11, and let's say 4 11s. I think that will do it. All right. So we can see a frequency plot. So this plot is telling us that in our data set there are 2 instances of the number 9, there are 3 10s, and 4 11s. Now, you might think about how would we find the mean of this? Well, we might want to try that leveling out thing that we saw. Unfortunately, that's going to be very misleading because it's going to tell you a different value than what you think. So if we, well, I'll show you what the mean is in a second, but if we do this leveling out procedure, what we're going to find is, right, we can think of taking this one value on the top of the stack for 11 and moving it over to the 9, and then there'll be 3 in each stack, and so we think, the mean isn't 3. But that doesn't really make any sense because all the values in our data set are 9, 10, and 11. How would the mean be 3? So the problem is that a frequency count is telling you how many of each item there are. And so really what that leveling out is telling us is that the average height of a stack is 3, but that doesn't really relate to the values in the data. So if we think of this as an equal sharing, right, there's actually, how many data points are there? There are 9 data points. So we would want to add up all these values and then distribute them equally among 9 to find out what the mean is. And this graph is nice because it can tell you what the mean is, or at least it'll show you on the graph where it is. So the mean is a little bit more than 10. And if you take the time to do the arithmetic, you'll see that that should be true. So that's a little cautionary tale about frequency plots. You want to make sure that you can understand what your representation of the data is actually telling you. And so that's why I tend to favor the equally sharing perspective of mean most of the time. But another useful one, especially for kind of eyeballing the mean in a data set, when you have a visual of the data set, is you can think of the mean as a balance point. And so if you think of these dots as like stacked on a plate, the mean would be where you would want to put your finger to try to balance those dots, right? And so another data set that might help us illustrate this is if we had, let's say we had 3 9s, and then 3 11s. I should have clicked that before, but so then, yeah, you can imagine where would you want to put your finger to balance these things if they were like, if these data points were stacked on a plate. And yeah, you could see you'd want to be right in the middle there. And if we added another 11 onto the list, then we know that, I mean, you can imagine that now it's a little bit heavier on that right-hand side, so we'd probably want to scoot our finger over to the right a little bit, right? And that's what happens there. It's just a little bit to the right. And then similarly, if we even put just maybe one data point down below 9, so let's say we do 5, right? That's going to make the balance, if all these dots kind of weigh the same, that's going to shift the balance over quite a bit. And so, I don't know, I'd invite you to hypothesize. What do you think? Where do you think the balance point is going to be for this data set? You can see it's still close to 10, but it's shifted over to the left because of that kind of term out on 5. And so balance points can be a nice way to think about where the mean is when you're just visually using a data. It's not good for calculating exactly, but it'll give you a feel for roughly where it is. So this is the standard data set that it comes with. I'd invite you to think about, where is the mean of this data? Where could we see the balance point for something like this? Yeah, and in this case, it's going to be right in the middle. It's nice and symmetric, right? And that's actually another feature of the mean. When the data is symmetric, the mean is going to be a pretty good measure of what we think of as the center of the data. Now, what I want to show you is the mean is what we call a little bit sensitive to either skewed data or outliers of data. So for instance, if I put one element way over on 19, 19 isn't really on the thing, but we can scoot out a little bit. There it is. You can see that the mean shifted over because of that. And what I want to do is kind of compare that to the median. So remember that the median is always going to tell us, when we arrange the data in order, we want the middle element. Or if there's an even number, then we want to kind of take the mean of those two next to the middle. And what you'll see here is that when we add these kind of outliers that shift the mean over a little bit, the median doesn't change. And so what we say is that the median is not so sensitive to those ideas of outliers. Another interesting difference between the mean and the median, so let's refresh this again, is let's say that we want to skew the data. So instead of the data being nice and symmetric around 10, we want it to be a little bit heavier on the right-hand side, let's say. So I'm going to take out one of these 10s, and then I'm going to put in another 13 and another 14. Like 2 more. I really want to skew this a little bit more. Well, 1414, that's not what I meant. Okay, right, so now the data is a little bit more skewed to the right, and so if we plot the mean, the median did move too, so that kind of shifted everything over to the right a little bit. So the median tends to be less sensitive to that, but it still is going to end up being the middle in some sense. All right. And similar things can happen if we skew it to the left. So what I'd like you to do now is I'm going to pause the video, and I have some tasks that I'd like you to try. I'd like you to try to come up with 2 different data sets that have a mean of 6. So go ahead and pause the video and give that a try. All right, so, well, there's kind of a cheater way to do that. If you make a data set that's all 6s, then certainly the mean is going to be 6. That's not really very interesting. What's more interesting is to try to use this idea of balancing to see if you can do it. So for example, let's say I started with a 3, and I know I want the mean to be 6. So how could I put another data point in here that would make the mean 6? Well, I have a data point that's 3 below 6, so maybe if I put a data point that's 3 above 6, I can get a mean of 6. Okay, and similarly, we could do something like, let's say I put a 1 in there. What would I need to balance that out? Well, I went kind of 2 below 3, right? I added 1 there, so I should go 2 above 11. I'm sorry, 2 above 9 and get 11. And then the mean is still 6. So that's another way to think about balancing that. So now what I'd like you to do is, after, try to make a data set that has a median of 3. Go ahead and pause the video and try to make a data set that has a median of 3. All right, so to do that, if we want to think about this, we want 3 to be in the middle. So, one kind of simple way to do that would be if we did 1, 2, 3, 4, how high would we have to go? Well, if we just put in a 5, now 3 is the exact middle, so is the mean. So what else could we do? Well, as long as the data is in order, we can always see that the median is going to be in the middle. And so we could, what's going to happen if we put a 2 in the beginning? Well, then the median is going to be, so there's 3 numbers below 2, counting 2, and there's 3 above. So it's going to be right in between there, right? So the median in this case would be 2.5. So if we put another number above, like if we put in another 4, now we have this. This is a case where the mean, why is there 2 times 2? I didn't mean to do that. That's weird. Huh, okay. Well, now the mean and median are the same. I don't know why it got mixed up there. But yeah, anyway, so we want to have the 3 in the middle. All right, so what we'll do is in the last segment, we'll talk about which one of these is the best measure of center. All right, so in this final segment, I want to talk very briefly about which is the best measure of center. And of course, the answer is it depends on the data. There is no one measure of center that's the best. It depends on what you're looking at. And so in general, for numerical data where we're measuring things, the mean is good for relatively symmetric data. Okay, where data that is kind of has like a center where a lot of the data is clumped, and then as you get out from that, it kind of tapers off. But symmetric can also mean something that would have like 2 humps, and that's not going to be very good for the mean either. Because, for example, if you're talking about, as kind of a ridiculous example, the heights of jockeys and the heights of NBA players. So if you're taking the heights of athletes, that's going to be pretty symmetric, but jockeys tend to be a little shorter, right? And NBA players tend to be on the taller side. And so your data is going to have these kind of 2 peaks to it. And so the mean in there is going to be right in the middle, which isn't really representative of the data. So we wouldn't say it's a good measure of center. But if your data is symmetric, kind of around and clumped, then the mean is going to be a good way to talk about what the middle or the center of the data is, kind of a typical data element. The median is going to be preferred when you have data that is not symmetric, so it's like skewed to one side, or if there are really big outliers, either big or small. And so some of the places that you see the median a lot are in housing prices, because the housing prices tend to be kind of clumped, but then there are often very, very expensive houses, and only a few of them that really throw off the mean. And so the median is a better measure of center in that case. And the same thing happens with income. Those are 2 examples of cases where the median is really a better measure of center than the mean. The mode is usually the best for data that we want to put into categories, which is something you can't use the mean for. So here's an example of something where you can't really use the mean. Is if we want to talk about what are people's favorite flavor of ice cream. Well, there's no way to average chocolate and vanilla, right? Those are not numerical data. Those are just categories. And so what we would be interested in is the mode, right? What's the most frequently occurring response? And in this case, it's chocolate, as you can see from this one survey that I was able to find from last summer. And so the short answer is different measures of center are useful in different scenarios. Like depends on what your data looks like and what kind of data you have. But there is your brief introduction to mean, median, and mode.